Hi guys, I'm Peter. Today I'm going to talk about this problem, 113, whose name is pass sum 2. In this problem, we are given the root of a binary tree and an integer target sum, and we need to return all root to leaf paths where the sum of the node values in the path equals target sum, and each path should be returned as a list of the node values, not node references. Okay. And it also says a root to leaf path is a path starting from the root and ending at any leaf node, and a leaf is a node with no children. Okay. Let's take a look at the first example. The binary tree is like this. Okay, and the target sum is 22. So we can find two paths matching the rule, matching the condition. The first path is starting from the root and ending at this leaf node. Okay, so 5, 4, 11, 2. These values sum up to 22. Okay, so this path is a path we need to find. And the second path we need to find is starting at the root and ending at this leaf node. So the values in that path are 5, 8, 4, 5. These values also sum up to 22. Okay, so what we need to return is a list, and in that list we have two lists. Okay, and it's like this. Okay, and let's take a look at the second example. The binary tree. Okay, the binary tree is like this: 1, 2, 3. Okay, so actually in this binary tree, root to leaf paths, there are two root to leaf paths, right? The first one is this, the second one is this, right? So 1, 2 and 1, 3. We can calculate the sum of them. Okay, the first path, the sum of the values are 1 plus 2 equals 3. Okay, the second path, the sum of the values are 1 plus 3 equals 4, right? So neither of them are 5. So we need to return an empty list. Okay. Let's take a look at the third example. 1, 2. So it means the graph is like this, the tree is like this. 1, 2. Okay. Root the node value of the root is 1, and it has a left child node, and its value is 2. Okay, so we have only one root to leaf path, right? So 1, 2, and the sum of these values, 1 plus 2 equals 3. 3 is not 0, so we also need to return empty list in this case. Okay, and in the constraint, we can notice that in the binary tree, actually in the binary tree we of course we can have no nodes. Okay, we can have no nodes, so we need to be aware of this. Okay, how do we solve this problem? Okay, let's use Python to solve this problem first. Okay, actually I'll use a DFS approach, and which will utilize recursion. Okay, first, because we will need to return a list, right? So let's have a IES variable which is a list, and we will initialize this as an empty list first, and at the end we will return it. Also, we will have recursive function. Okay, we will have a recursive function to help us find the all paths matching the rule, right? So let's define this recursive function. We name it as DFS. Okay. The first parameter of this function should be the node. Okay. So when we call this function, we need to pass the root. Also, we need to keep track of the paths until current node, right? So we will also have a parameter which is called path. Okay, we can name it path. Okay, and when we call this function, we will pass a empty list. Okay, and we also need to have a remaining sum, which means the value. Okay, the value until now. What was the value remained? We named it remaining sum. At first, at the beginning, I'll pass target sum to it. Okay, so because DFS, okay, this function is a recursive function. So about the recursive function, what we need to think about is what's the base case, right? If we don't think about, we don't consider the base case, it will happen stack overflow, right? So the first things we need to think about is what's the base case. It's the node is null, right? If the node is null, if the node is null, we just need to return right away. Okay. Otherwise, the first thing we need to do is we need to add the value of current node to the path. Okay. And also need to update the remaining sum. Remaining sum, okay, we need to subtract the value of the current node from it. After that, we need to check, is the current node the leaf node? Okay, we need to confirm this first. So if the current node is a leaf node, the conditions will be if node dot left is none and the node dot right is none, which means it has no children. If these conditions happen, which means the current node is a leaf node. Okay, and also if one more condition happens, which is remaining sum is 0, because we already subtract the value of the current node from the remaining sum. So in this case, we checked is the remaining sum equals to 0 or not. Okay, if these conditions happen, which means we already find a path to match the rule. It's a path. The current path is our target, right? One of our targets. So we need to append this path to RES, right? But the thing is, we need to really be careful at this point. Is for example, in this example 2, okay, if target sum is 3, okay, if target sum is 3, and we will do the recursive explore to the left subtree, right? 1, 2, and we found a path 1, 2, right? So we append the path to the IES variable, so which means it will become this, right? 1, 2. And after that, we need to pop out. We need to go back to the parent. Okay, and we need to pop out. So we need to pop the final element in the path variable. So which means, and actually if we just do this append path, the path actually is the reference. So when we pop the element in the path variable later, actually it will influence the list which we added earlier. Like when we pop the two element, these two, then the list already been added to this IES will also be influenced and will become this. It's not our expectation. It's not what we want, right? So at this point, we need to create a new list, and the content of the list will be the values in the path variable. Okay. So which means if we do this, okay, later when we do the operation on the path variable, we won't influence the list we added to IES. Okay, that's a very important point. After that, we need to do the recursive call. And pass the node.left to it. And path variable is the same, remaining sum is the same. And for the right subtree, we also need to do the same thing. Okay, so after exploring the left subtree and the right subtree of the current node, after we finish that, we need to go back to the parent, right? So remember to because we in this whole function we use the path variable, the same path variable all the time. Okay, so we need to after that we need to do the pop. We need to remove the last element of this variable. Okay. Okay. So that's it. Let's submit to check. Okay, no problem. Okay, what's the time complexity and the space complexity of this solution? First, I'll assume n is the number of nodes in a tree, and for the time complexity in the worst case is the when we have a complete binary tree, and the number of leaf nodes in a complete binary tree will be n over 2. Okay, and in each leaf node, we also need to create a new list and to populate it with paths, right? And potentially at the maximum, the path variable will consist n nodes, right? So about the time complexity calculation, we also need to multiply another n. So, and about this over 2, we can ignore it. So the result is the result of the time complexity will be big O of n squared. For the space complexity, it will be big O of n. Why? because we have a pass, a list variable, pass, whose name is pass, and potentially at the maximum it will consist of n nodes, n value, n elements. So for the space complexity, it will be big O of n. Okay, let's solve this problem also by using Java. So first we need to have this variable is, okay, we name it is to return, right? So and we will initialize it as an empty list first, and I'll use array list. And at the end, I'll return it. And we also need to have a recursive function, right? I use a private modifier, and because this function won't return anything, so I'll use void. I'll name it DFS, and the first parameter, the type of it will be tree node. Name it node, and also we'll have this parameter. I'll name it pass. Another parameter will be the type of it will be integer. I'll name it remaining sum. And also we also need to pass this res. Okay. So be like this. Code will be like this. Okay. So we need to at least pass some function. We need to call this DFS function. We'll pass root to it, and for the pass, we'll pass an empty array list, and for the remaining sum, parameter will pass the target sum, and for the is we will pass is. Okay. And about the base case of this recursive function, it will be if the node is null. If it's the case, we'll return right away. Otherwise, we'll add the value of the current node to pass. Okay. And also update the remaining sum. We'll subtract the value of the current node from it. And after these operations, we'll need to check the current node is a diff node or not. If the current node is diff node, conditions will be if the node.left is null and node.right is null, equals null. Okay. And also we need to check if remaining sum equals 0. If it's the case, which means we already find a pass matching the rule. So we need to create the new array list, and the content of it will be pass. Okay, content of it will be the values in the pass variable. Okay. So next thing we need to do is do the recursive call to pass the node.left, pass the same, remaining sum also the same, is also the same. Okay, and do the same thing for the node.write. After these operations, after these explorations, we need to go back to the parent, right? So remember to remove the last element of the path variable. Okay, that's it. I think that's it. Just do a submission. Okay, hey, what's the problem? Array list. Let's submit it again. What's the same? Do the submission. What's the problem? The same. Okay, no problem. Okay, that's it. Okay, thank you for watching.